Hello everyone. Today we are going to look into a very important branch of mathematics, that is trigonometry. You all would have learnt about different forms of triangles based on their sides and angles. Now here we are going to focus only on a right angle triangle as of now. Okay, and we are going to bring about the ratios between the sides and the angle that is given to us, and that is what we are going to do in trigonometry, studying about them. So trigonometry is the study of relationships between the sides and angles of a triangle. So let's consider a right angle triangle. Now we all know that this is the right angle and the side opposite to the right angle will be the hypotenuse, and let's consider this angle is theta for us. So this side, right, the side adjacent to the angle, the given angle theta, is nothing but the base. I denote it as B. And the side opposite to the given angle theta is nothing but the perpendicular, or we can just say it as opposite side. Some of us use that notation too, right? We are going to denote it as perpendicular P. So I repeat again. So in a triangle which is right angle, if the angle theta is given to us, next the side adjacent to the given angle theta, we call it as the base, and the side opposite to the given angle is called as the perpendicular, and this we already know, that is the side opposite to the right angle will be the hypotenuse. And we're going to make use of the Pythagoras theorem here, right? The Pythagoras theorem, sum of the squares of two sides is equal to square of the hypotenuse. So that comes up to the perpendicular whole square plus the base whole square equals to the hypotenuse whole square. Now if you want to abbreviate it, we can write it as P square plus B square equals to H square. Now, let's consider a right angle triangle. The given angle, we denote it as theta. The side opposite to the right angle, or the longest side, that is the hypotenuse. The side adjacent to the given angle theta, base B we denote it. And the side opposite to the given angle theta, the perpendicular, denoted by P. Now we give the 6 trigonometric ratios as follows. The first one is sine of the given angle theta, written as sine theta, which is nothing but the perpendicular by the hypotenuse. And the cosine of the given angle theta is the adjacent of the given angle, adjacent side of the given angle by the hypotenuse, or we can say base by hypotenuse. Next, tan theta or tangent of the given angle theta, written as tan theta, equals to the perpendicular by the base. And another way we can say tan theta is also sine theta by cos theta. So if you know sine and cos, we can find tan theta. So tan theta is also written as sine theta by cos theta. Now the reciprocal of sine theta is called as cosecant theta, and we are going to write it as cosecant theta equals to 1 by sine theta. So from this I can say cosecant theta is just the reciprocal of this. So the reciprocal of this is h by p, that is the hypotenuse by the perpendicular. So cosecant theta equals to hypotenuse by the perpendicular. Similarly, the reciprocal of cos theta, we write it as secant theta, right? In short, sec theta, that is equal to 1 by cos theta. So the reciprocal of cos theta, that is h by b. So from the diagram, cosecant theta is h by p, secant theta would be h by b, hypotenuse by the base. Now the reciprocal of tan theta is nothing but cot theta. So cot theta or cotangent, that is cot theta, we can write it as 1 upon tan theta, that is cos theta by sin theta. So I can say cot theta equals to 1 upon tan theta, that is equal to cos theta by sin theta. So cot theta equals to base by the perpendicular, base by the perpendicular. Now focusing once again from the triangle, the 6 trigonometric ratios, let's summarize it quickly. Sin theta is the perpendicular by the hypotenuse. Cos theta is base by the hypotenuse. Tan theta is the perpendicular by the base. Cosecant theta, hypotenuse by the perpendicular. Secant theta, hypotenuse by the base. Cot theta, base by the hypotenuse. Now, with these 6 trigonometric ratios, we are going to find out the standard trigonometric ratios of few acute angles, right? So theta can vary. we can find out for any acute angle, but here we are going to restrict ourselves to 30 degrees, 45 degrees, 60 degrees along with 0 and 90 degrees. So the next one, the trigonometric values of some standard angles. Now this is the tabular column that should be memorized. So let's see how to remember it easily. So in the tabular column, let's list out the angles, right? So horizontally 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Vertically, we'll list out the 6 trigonometric ratios, sine of the given angle, that is theta, which is sine theta, next cos theta, tan theta, cot theta, cosecant theta and secant theta. Now the easier way to write down the values. Learn sine theta, the rest of it are going to be very, very easier. The easier way to remember, okay, let me just show you how we get these values. So let's say this is nothing but 0, then write the numbers 1, 2, 3, 4 in the consecutive order. Now divide each of them by 4, 0 by 4, 1 by 4, 2 by 4, 3 by 4 and 4 by 4. Now consider the square root. Root 0 by 4, square root of each term here. Okay, now 0 by any number is 0. So this value is now equal to 0. Next, square root of 1, we know 1. Square root of 4, it is 2. So this would be 1 by 2. Now 2 1s and 2 2s. Here it is square root of 1 by 2, which is 1 by root 2. And here this is root 3 by 2. And here this is going to be 1. Okay. So now if you have to write these values, so sine 0 degrees is nothing but 0. Sine 30, it is 1 by 2. Sine 45, 1 by root 2. Sine 60 degrees, that is root 3 by 2. Sine 90 degrees, it is 1. Now let's look into the values of cos theta. We just write it in the reverse order. So let's go. Cos 0 degrees is 1. Cos 30 degrees is root 3 by 2. Cos 45 degrees is 1 by root 2. Cos 60 degrees is 1 by 2. Cos 90 degrees is 0. Now tan theta, we know that it is sin theta by cos theta. So just this by this term over this term, right? So tan 0 degrees would be sin 0 degrees by cos 0 degrees, 0 by 1. 0 by any finite number is going to be 0. So this value is going to be 0. So repeating again, tan 0 degrees is 0. Now tan 30 degrees, how do we write tan 30? Sin 30 degrees by cos 30 degrees, in short this by this. So 2 and 2 gets cancelled. If I put it like this, 2 and 2 gets cancelled, we are left with 1 by root 3. Now tan 45 degrees, this term by this term, 1 by root 2 by 1 by root 2, which is 1. Next, tan 60 degrees. So sin 60 degrees by cos 60 degrees. So if I put a slash like this, 2 and 2 gets cancelled, root 3 by 1. And tan 90 degrees, now pay attention here. Tan 90 degrees is sin 90 degrees by cos 90 degrees. That is 1 upon 0. Now, the denominator can never be 0. We have to say this as undefined. So tan 90 degrees is going to be undefined. Right? So summarizing all this again, the first three if you know, in fact if you know only sin theta, the rest all the terms could be written. Now for cot theta values, we know that cot theta could be written as cos theta by sin theta. So this value upon this. So cot 0 degrees would be cos 0 by sin 0. You can calculate it that way for each of the angles. Or another easy way to remember, we have already written tan theta values. Just write them in the reverse order. So cot 0 degrees would be undefined, cot 30 degrees would be root 3, cot 45 degrees would be 1, cot 60 degrees would be 1 by root 3 and cot 90 degrees is going to be 0. Now having got till cot theta, how about cosecant theta? We just spoke that cosecant theta is a reciprocal of sin theta. So just reciprocate these values. So sin 0 is 0. So cosecant 0 would be 1 upon 0, right? So that is going to be undefined. Just reverse these values, that's all. We get cosecant theta. So 2, reciprocal of this is root 2, reciprocal of this is 2 by root 3, and this is nothing but 1. So coming back to cosecant theta, what are all the values that are possible? Cosecant 0 degrees is undefined, cosecant 30 degrees is 2, cosecant 45 degrees is root 2, cosecant 60 degrees is 2 by root 3, cosecant 90 degrees is going to be 1. The same, we are going to apply it for secant theta also. Now we know that secant theta is going to be the reciprocal of cos theta. So just reciprocate these values. Just reciprocate the values of cos theta. So secant 0 degrees would be 1 upon cos 0, that is nothing but 1. And secant 30, reciprocal of this, that is 2 by root 3. Secant 45, reciprocal of this, that is root 2. Secant 60 degrees, reciprocal of half, that is 2. And secant 90 degrees, again pay attention to this. Secant 90 is going to be 1 upon 0, that is nothing but undefined. The moment you see a 0 in the denominator, a finite number by the denominator being 0, we say it as undefined. So these are going to be the trigonometric ratios, right? So the 6 trigonometric ratios: sin theta, cos theta, tan theta, cot theta, cosecant theta and secant theta for the standard values 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. This should be memorized.